Very quickly, I'll give you like, probably 7 to 8 minutes, a very quick elevator pitch about GridGain and about in-memory data fabric and what we do. So very quickly, there's a couple of history. By the way, my name is Nikita Ivanova. I'm a founder and CTO of the company. The GridGain is a in-memory data fabric. It's a pretty old, pretty mature project. We started about 10 years ago, 2005. In 2007, we got the first release out. In 29, we had a pretty large customer already with about 2,000 nodes in production. And in 2010, we got enough traction going on that we have about a start of our software every 10 seconds. So there was a former company behind it. What's kind of interesting, in 2013, we were clocked and benchmarked to really achieve about 1 billion transactions per second on a 10-node cluster. In 2014, we've been an open source project from day one, but in 2014 we decided to go on Apache Software Foundation. In 2015 we actually graduated to become a top-level Apache project in the same family as Hadoop and Spark and everything else. So what is in-memory data fabric? Very simply, in-memory data fabric is an infrastructure software that slides in between your applications and your data sources. And it gives you two things. It gives you performance and scalability. It gives you performance by moving data from flash and disk to RAM across multiple computers, and it gives you scalability by parallelizing this processing, storage and processing. So this is right there in the middle. So you can essentially have a variety of different applications, whether written in Java or JVM-based languages like Java and Scala, or .NET or C++, connect to this data fabric, and we allow you to move data from a variety of data sources, SQL, NoSQL, Hadoop file systems, into the in-memory data fabric, and things go fast. That's the fundamental idea of a memory data fabric. Things will go dramatically faster than before. We typically outperform any flash or disk-based storages by at least order of magnitude, typically by 2. Take Cassandra, take MongoDB, we outperform all of those by a factor of 100. Not because we're smarter, we're not, but we move things in memory, and once data is in memory, you can take advantage of that very effectively. So why we call it a memory data fabric? Well, it's a fabric. We tend to give you a very, I would say, very strategic canonical view on the memory processing. Not only we give you the basic key value memory store, we give you the full data grid with transactions and SQL support. We give you compute grade. So if you guys are from HPC background, high performance computing background, MPI, MPP, those things, rings the bell, we support them as well. We'll give you a streaming processing in memory. We'll give you a full SQL 99 and transactions in memory. We'll give you Hadoop and Spark acceleration, things like advanced clustering. For example, we're giving you in-memory file system. So all those different things really make a fabric, and that's what we're basically known for. We not only give you kind of one-trick pony deal, we're giving you a full fabric. You can guys use it as much as you like for all your in-memory type of processing needs. So that's the idea behind in-memory data fabric. So let me give you some example. So about 3 years ago, we participated in a tender for largest bank, one of the largest banks in Europe, number 3 in the bank in Europe. It's called Sberbank. It's actually number 1 bank in Eastern Europe and Russia. And the idea was pretty simple. They were looking to really replace the entire kind of Oracle infrastructure in the bank with in-memory systems, in-memory type of architecture. So the idea was to migrate to entire data grid architecture, minimize dependency on Oracle, and kind of move to open source. So this is kind of a picture of what they're trying to do. It's a very traditional architecture, nothing new here. You have your apps on the left, you have some security, and basically have in-memory infrastructure here. Really key here is not that we won the standard between all the different vendors, but the type of performance we're able to achieve. So, couple of notes about this, POC. They were basically trying to see if there's any type of software that could support change, recalculation of the risk for entirely bank portfolio for every tick on the market. Now think about this. There's a global bank. There's millions of individual positions it has in portfolios. They're trying to recalculate the risk of that global portfolio on every tick on the market. Is that possible? So to make the long story short, we were about the only software that will be able to actually achieve that. And the numbers we achieved is pretty remarkable. Look at these numbers. Literally, we were able to achieve a billion transactions per second. And I'm talking about a real asset transactions per second on 10 commodity Dell blades. Those 10 commodity R610 blades from Dell with total capacity 1 terabyte of RAM. Literally, the entire cost of these 10 blades was $25K. Dell blades, the whole network, the whole power supply, $25K. Now let's just sink in your mind. Think about this. On $25K worth of hardware, you can achieve a billion transactions per second. Think about this again. On $25K worth of hardware, you can achieve a billion TPS. Those not a fake transactions, those are full asset transactions per second. Just to give you one comparison, if you take a Oracle, Exalytics, Exadata entire shebang, you can probably get to about 15 to 20 million transactions per second on Exalytics, Exadata type of hardware. You're going to spend millions of dollars on this setup and you get about 15 to 20 million transactions per second. We got in this particular POC to a billion transactions per second. Numbers like this were literally a part of a science fiction 7 to 10 years ago. You weren't talking about any billion TPS at all. You were talking about millions of TPS as the absolute dream. And today, you can literally take an open source software, free software, get a measly cluster from eBay for less than 20K today. That was 3 years ago. And get to the 1 billion TPS per second. And think about this, what can you do with a billion transactions per second type of processing? You can do quite a lot. Just to give you a perspective, literally a few years ago, the entire Twitter working set was about 7 terabytes. So you can basically multiply it by 7 cost-wise in 70 years money back and get the same billion transactions per second processing on a Twitter working set. That's basically a big deal. So that's it. Fundamentally, that's all about it. Forget about this big GridGain, think about in-memory computing. In-memory computing can give you that boost. This is the software and type of processing can give you from minutes to milliseconds, from seconds to microseconds. The last slide I have here is, first of all, thank you. And by the way, we're at the booth 1619 right there, diagonally over there. And if you want to learn more about in-memory computing, you can join the Memory Computing Summit. We'll be in San Francisco. We're going to be part of this as well. So look at this in the Memory Computing Summit. And thank you guys for sticking around at 6:30.